Hi guys, I am going to teach you guys about the second half of the 1.3 notes today. I'm going to do it on paper so that you can see my hand doing all of the things that you would see me doing either virtually or in person. Today we're going to be learning about median, quartile, upper quartile, lower quartile, finding outliers mathematically, and then we're going to be finishing off with making box plots. So I'm going to start with some vocab, quartiles. If you want to look along at your slides to get better, more full definitions, if you're someone who writes down every single word, you can go into the slides on Google Classroom. I'm just going to be quickly going through some of the major points in the definitions. So quartiles split data into 4 equal sections. So there's approximately an equal number of data points in each quartile, between each quartile. The first quartile is the median of the lower half of the data. The second quartile is actually the median, and the third quartile is the median of the upper half of the data. So usually when you find these, you find the second quartile first. This is really just your median. No one really ever calls it the second quartile, but that's another word for it. So the second quartile is actually just your median. It's the middle data point. Or if you had an even number of data points, it would be the average of the two middle data points. All right, so first you find your second quartile, and then you would go ahead and find your first and your third separately. So the first quartile is the median or the middle value of the lower half of the data. Median of the lower half. And so the third quartile would be the median of the upper half of the data. All right, so you see a little example here on a dot plot. Normally you just do this by data values. Here you see the median or the second quartile is right in the middle. In the middle of the lower half of data, notice there are 3 data points to the left of the lower quartile and 3 data points to the right. So that's the median of the lower half of the data. And then the third quartile, sometimes called the upper quartile, you have 3 data points to the left, 3 data points to the right. So the inner quartile range is the middle 50% of the data. So it's the distance between Q3 and Q1, or Q1 and Q3. So in order to find the IQR, you do Q3 minus Q1. So IQR equals Q3 minus Q1. There you have it. So let's do a quick example. If you're doing the type-in notes, you can type this in. If you're doing notes on your paper, just have these definitions written down. And then instead of just writing down the data values that I'm giving you, just write them in order. So when you are trying to find these values, you first have to put them in order from smallest to largest. That is the most important first step. So I am going to first order the data. So here are my data points. If you're looking along at the slides, then you can see the data points on slide 43 on the slides. So I'm going to first find my lowest and my highest and go from there. I think 5 is my lowest. And then I think I'm going to 10. 15 is next, and I have a couple 15s. I think I have 3, 4. Then I've got 20. Notice I'm crossing them off as I go so I can make sure that I'm doing this accurately. 25 is next. Then I've got 30, 2 30s, 2 40s, 45, 60, 60, 65, and 85. All right, so I've crossed each one off. So here I have them in order. Now, in this particular example for my notes, I had enough boxes, exactly as many boxes as I needed. But for you guys, if you're ordering them, now the data says I have 20 data points. So once I order them, I should go back and make sure I still have 20 data points. If I have 19, then I know I missed one. It's so easy to miss one when you're crossing them off. All right, so now I'm going through my example of finding each of these values. So remember, Q2 is where I start. This is my median. So first I find my median by crossing off side to side. So if I cross off side to side, at the same time though, I don't want to cross off because I need to then use these values to find Q1 and Q3. So if I cross off, I have 1, 2, 3, 4, 5 on the left. 1, 2, 3, 4, 5 on the right. 1, 2, 3, 4 on the left. 1, 2, 3, 4 on the right. And now I'm narrowing it down to these two values. That's where my median is going to be, or my Q2. Now, since I didn't narrow it down to just one value, I need to find the average of this. So my median is going to be 20 plus 25 over 2. So that's 45 over 2, which is 42.5. Not 42.5, 22.5. So now, since my median was not one of the actual data points, whenever you have, whatever your median is, you don't include it when you start crossing off for your Q1 and your Q3. So 22.5 is right here. So now when I go to find my my Q1 and my Q3, I'm going to start, basically I'm going to pretend the other half of the data does not exist, and I'm going to cross off using that. So now I'm crossing off on either side. So now 20 wasn't my median, so I'm including it in my crossing off. So I have 1 and 1, 2 and 2, 3 and 3, 4 and 4, and here is where Q1 is going to lie. Now 15 and 15, there's nothing in between those. So 15, if I wanted to be technical, 15 plus 15 over 2 would be my Q1. So it's going to be 15. So now I'm going to pretend that side of the data didn't exist, and I'm going to cross off on the other side. So I've got 1, 1, 2, 2, 3, 3, 4, 4, and this is where my Q3 is going to be. So that's between 40 and 45. So I have 40 plus 45 over 2, which is 85 over 2, and that one's going to be 42.5. So now, basically what you just realized is I'm finding the median of 3 different data sets, basically. I find the median of this one, and then I pretend the other half doesn't exist. I find the median of that one, pretend that side doesn't exist, find the median of that one. Now my IQR, again, is Q3 minus Q1. So that's 42.5 minus 15. Go to your calculator, 42.5 minus 15, and I get 27.5. So there's your example of finding Q1, Q2, Q3. Always start with the median, then do the two sides. Order it, find the median of the two sides. All right, so once you have all of that, now you can go on to identifying outliers. These are all important features of identifying outliers, so make sure you understand this before going forward. All right, so I have said before in this class that at the beginning, we're just using outliers based on visuals. Now we're gonna actually show you the formula for finding outliers. So I have low outliers and I have high outliers. So in order to find outliers, you need to know the formulas. So you can have outliers on the low end, which mean that the value is less than Q1 minus 1.5 times the IQR. High outliers mean that the value is greater than Q3 plus 1.5 times the IQR. Now this seems very abstract to start, but I'm going to show you it in clear terms. So what I need to do to start is I need to find what the IQR is. And in order to find the IQR, you need to find Q1 and Q3. And in order to find Q1 and Q3, you need to have first found Q2. So I'm going to find all of that with this data set here. All right, so it's already in order. So I'm going to start by crossing off. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. 1, 2, 3. 1, 2. 1, 2. And I see my median is 22.4. So that is Q2. Now notice this is actually one of the data points. So now from here, I actually don't include that in my crossing off. Before, I didn't have one of my data points and I had all of my values included in my crossing off. So now I'm just looking less than this in order to find my Q1. So now I'm finding the median of this set of data right here. And that's going to be Q1. So I'm going to do 1, 2, 3, 1, 2, 3, 1, 2, 1, 2. And I see my median is right here between 22.2 and 22.2. So my Q1 is going to be 22.2. Now I'm going to look at the upper half of the data. So it's from there to here. I'm going to pretend the lower half doesn't exist. So I've got 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, and I can see my Q3 is between 22.6 and 22.6, which means it is 22.6. So there's a second example on finding Q1, Q2, Q3. Now for my IQR, that's again Q3 minus Q1. So that's 22.6 minus 22.2, which is 0.4. So the IQR is 0.4. So now I need to use these formulas. So this is generally called the 1.5 IQR rule. So here, the formula for the lower outlier, you use Q1. So Q1 minus 1.5 times the IQR. So Q1 is 22.2 minus 1.5 times the IQR is 0.4. That's how I set it up. So that gives me 22.2 minus, and then 1.5 times 0.4. And I'm getting 0.6. So 22.2 minus 0.6, and I get 21.6. So now I go into my data and I look, where would 21.6 fall? And it would fall right here. So what that says is 21.6 is the absolute lowest possible point that you could have and it not be an outlier. So that means 21.5 is an outlier. If you look at this on this graph here, 21.6 would be here. And if I drew a little dotted line, you can see that this is a low outlier. So that point is less than Q1 minus 1.5 times the IQR. So a low outlier would be 21.5. Now I'm going to go ahead and find if there's any high outliers. So Q3 is 22.6. And then I've got plus 1.5 times the IQR, which is 0.4. So 1.5 times 0.4 is 0.6. So 22.6 plus 0.6. So that's equal to 23.2. Now again, I'm going to place that on my data value like number line. 23.2 would be between these two values, which makes 23.3 a high outlier. If I go to my number line, my dot plot, 23.2 would be right here. And so this is a high outlier. So that is how you mathematically find if there are outliers. So in your practice that goes along with this video, you're going to end up needing to use this math in order to find out if there's outliers. Now it's no longer okay to just say, oh, this one looks like it's a little bit off, so it's an outlier. Now you actually have the math to back up your opinion as to why it's an outlier. Sometimes things look like outliers and they're not. So just be careful of that. All right, so there are 3 reasons why you might look for an outlier. Number 1, they might be inaccurate data values. And what I mean by this is that sometimes data entry is incorrect. The other day I made a worksheet for another class and I typed 12 instead of 102. So that's an inaccurate value. So sometimes it's just, it wasn't meant to be like that. So number 2 is that it can indicate a remarkable occurrence? If you think of snowfall and you think of some of the major storms, when you look at what storms get talked about historically, they're generally talking about those outlier storms, the storms where you got way more snow than you get in other storms. So likewise with rainfall. So when you're looking at like thresholds of when things might start to get bad, you're looking at what the threshold is and when it becomes an outlier in the data. If it's an outlier, then you might have a remarkable occurrence that you need to treat differently than other things. And lastly, they can heavily influence statistics. Now, what I mean by this is, say I'm trying to get some statistics about a test I gave. So let's say 2 students didn't actually take the test in one of my classes. If they have zeros in my gradebook, they're considered outliers because they're going to affect the statistics of the entire class when they didn't even take it. Whereas if everyone got if some people genuinely got a really low grade, those might be outliers, but they're more valid data points than the zeros that people got because they didn't actually take the test. So when you're looking at how different data points influence statistics, you actually want to make sure that it's a valid data point. Like, it's not just that someone didn't take the test, it's actually that they did that poorly on the test. So hopefully that's not a case in here, but that is a reason to actually look for outliers. All right, so moving on to our last part. So when you find out if there are outliers, what your Q1, Q2, Q3 are, now you're actually going to be putting this into a box plot. So when you make a box plot, you have certain steps. So these steps are outlined on, let's see, slide 63 through 70 on your slides. So if you want to write down these steps, these are your steps. So I'm using the same data set that I just used on the last page. So I already have my Q1, Q2, Q3. I'll rewrite them on this page though, so you have it. So this is my data set in a box plot form. Actually, they're already up on the top. So my data set in a box plot form. in a dot plot form. So first, I need to find the 5-number summary. The 5-number summary is that Q1, Q2, Q3, and the max and min. So minimum, Q1, median, Q3, maximum. We will work more and more on finding a 5-number summary in this class. Then you want to identify outliers. In the last page, we decided that this was an outlier, 21.5, and we decided that this was an outlier, 23.3. We identified the outliers. Then we want to draw a horizontal axis and label it. So notice I have a horizontal axis down here. My data values go from 21.5 to 23.5. So I just have that exact same number line that I do for my dot plot up here. Now I want to plot the 5 numbers. I want to plot the 5-number summary. So what I'm going to do here in a box plot, I'm going to put some points here. So my minimum is 21.5. I'm just going to put a dot here. My Q1 is 22.2. My Q2 is 22.4. And my Q3 is 22.6. And then my maximum is 23.3. Okay, so in a box plot, your box consists of the middle half of the data. Your IQR is actually where the box is. So I'm going to draw a box from Q1 to Q3. So draw a box from Q1 to Q3. And a line down the middle of the box at your median. Now here is the tricky part. So you need to determine how far out your whiskers go. So your whiskers go to the data point that is within your 1.5 IQR range. So I'm just going to draw a dotted line where that is. So 21.6 was where the lower outliers were cut off, and 23.2 was where the high outliers were cut off. So my whiskers cannot go past that point, but they need to extend to a data point. So if I go back to this data set from back here, my highest or my lowest data point within that range is 21.9. So my left whisker is going to go to 21.9 and stop there. Now looking at the other side, my highest data point that was below that 1.5 IQR rule was 22.9. So I'm going to have my right one go to 22.9. So it only goes there. Now, how to acknowledge that I have 2 points that are not technically a part of this box and whiskers. So if you don't go to the max and min and you have outliers here, you have to draw stars for them. So usually like the little asterisk key, you draw a little asterisk here. And that notates that you have outliers out there. Now these dotted lines are not necessarily a part of the box plot, but I do draw them to help me realize how far out my whiskers go. And I also think another really good strategy is to circle or draw a line on your data set and then circle which point is within the 1.5 IQR rule, but not outside of it. So notice the red ones, these are outside, so they are stars. These ones are inside, so that's where the line goes to. So there it is. If you're doing this online, I tried to make it so that you could actually click into it and adjust it, but hopefully it worked for you. And there is your box plot. So the last thing I'm going to say in this video is just to make sure you complete and answer every single question that was asked in this section, and then go through and try your 1.3 practice part 2. I recognize that this is not a situation where you can ask me questions in person because of the type of school day it is, but do your best and we'll answer any questions on Friday when we see each other. Thank you.